when we say the word momentum, it's very simple. Momentum is just the product of force and velocity. If you want to define it, it is quite easy. The product of momentum is the product of mass and velocity. Sorry, beta. Mass and velocity. Simply. And momentum is represented by a small letter p and the product of mass and velocity, mv. So it's not something very difficult or very you can say out of the box for us to understand the momentum, because as we are moving around, we do have the momentum. Okay, you just move around and you just have your mass and you just are moving with certain velocity, you have the momentum. Okay, and if some heavy person is moving with the same speed as you are, he has the higher momentum. On the other side, if someone is lean than you but he has more velocity, he's running with high speed, he'll have the equal or more momentum, because momentum is the product of mass and velocity. Hope you got it. All right.
Yes, sir.
Okay, this is you have also studied in your IGCSE the product of mass and velocity. When we talk about the units of this, so simply this is the product of mass and velocity, as mass is measured in kilograms and velocity is measured in meters per second. So its unit is kilogram meters per second, which can be maneuvered. We can do little maneuvering to this, I can say this is kilogram meter second minus 1, and I write second minus 1 and I write second plus 1. Will it be any harm to the situation? No, not at all, because 1 second minus 1 second plus 1, they are always cancelled. So actually this is again equal to kilogram meter second minus 1. So there isn't any change. But this will be giving me one advantage. If I join these two second minus 1s, it becomes kilogram meters second minus 2, and then the second plus 1 can be written as simply, and this is overall called Newton. So you can also write the unit for the momentum as Newton second, but basic unit is very clear, kilogram meters per second. So this is little maneuvering which I have done, but if somewhere the unit is written Newton second, so you shouldn't be worried about it. It's also the unit, it's the replacement of kilogram meters per second, but there isn't any change, it is exactly the same. This is the first thing about the momentum which we must know. Like there is a truck whose mass is given to you, the mass is 5,000 kilograms, and its speed is given, it's moving with a velocity of for example 10 meters per second, and you are asked to find the momentum of the truck. So you would simply find it's the product of mass and velocity. So you will multiply 5,000 with 10. So you will write it is 5.0 into 10 raised power 5 kilogram meters per second, or simply you can write it as 5.0 into 10 raised power 5 Newton seconds. So both can be written. So there isn't any issue in writing Newton second or kilogram meters per second. All right. So we are clear that the momentum is the product of mass and simply velocity, and we have to talk about the momentum. So the momentum is basically, we have to directly talk about some kinds of collisions, and momentum is linked with collisions, because simply the momentum is very simple. Anybody can have the momentum if it is moving and it has some mass. Otherwise, if there isn't any movement, there will be no momentum. So it's so simple, but it becomes little complex in the case of collisions. What collisions? Definitely we do not like the collisions normally in our daily life, as the collision mean accident. Accident mean this, the collision of your vehicle with some other vehicle, or the collision of your vehicle with a wall or with some obstacle at rest. So that definitely damages, that gives the loss to the property and life as well. So we do not like it, but it is there. We have to talk about it and we have to discuss this as well, because the car manufacturers take a notice and they just give you a maximum load which you can put, maximum number of persons which who can ride their their vehicle, because they have to do the calculations on the basis of momentum, and they also give you the top speed which you can run your vehicle. So these both are used to get the actual momentum of your vehicle, because in case of collision there are safety measures, there are safety, you can say, there are safety, you can say, gadgets installed in the vehicle. They can just manage to save you if you are within that particular limit of momentum. But if you have increased the load in the vehicle, you had more momentum. So in case of collision, you'll have more severe damage to yourself and to your vehicle. So that's why we have to follow the set, you can say, information by the companies of the car makers, but we do not follow them. We normally violate them. But in case of collision, momentum becomes very interesting. We start with the collision of two small balls. One ball has a mass m1. It is moving with velocity u1 in this direction. There is another ball which might be smaller in mass. Its mass is m2, but it is going in this direction. Its velocity is u2. Definitely they'll have a collision in the center. There will be collision. After collision, they can have the different situations. Your heavy ball continues to move in the same direction, but now the velocity would be changed. I'm calling it v1. And your smaller ball has also collided and just rebounded back m2, and the velocity is also changed. That is now v2. So this might be the situations can be any. But whatsoever the situation is given to you, according to that, we have to find out the law. We have to apply a law that says that in the case of collision, total momentum before collision, I'm writing total momentum before collision is always equals to the total momentum after collision. So what is the total momentum before collision in this case? As you also remember that momentum is a vector quantity. So you have to take care of the direction. We have to not violate it, that we have to take care of the direction. For example, if this is normally this direction is taken as positive, and the direction which is opposite to this is always taken as negative. So this u2 would be minus u2 in our case. So when we go for the momentum of the first body, that would be m1 u1 plus m2, but minus u2. What I have written, I have just put it this negative sign myself. Examiner is not going to give us this sign. Knowing the momentum is a vector quantity, it has the direction, so that's why I put the direction. And what about after collision? Both are going in the same direction, which is positive. So we do not need to go for any kind of the negative thing. m1 v1 plus m2 v2. Now you can just make it equation m1 u1 minus m2 u2 is equals to m1 v1 plus m2 v2. And in place of these m1s and m2 and v1 and v2, we can have the values if we are facing any real life problem or situation. If the masses are given, m1 and m2 are given, and the velocities are given, like if three velocities are given, you can find this one. If not given even, you can find it. All right, Marisha beta?
All right, sir.
Okay, simple. This is called the law of conservation of linear momentum. We also call it law of conservation of linear momentum. I have added a word linear here. Do you understand what does this linear mean here, and why I have added this word over here?
Like in a straight line?
Yes, it's a straight line. You are 100% right. It's a straight line. When you're moving in a straight line, this is called the linear momentum. So law of conservation of linear momentum mean we are talking about only the bodies which are moving in straight line. So this is the law which is always conserved, because whenever there are collisions are of two types. It might be elastic or it can be inelastic. If it is elastic, momentum is conserved. If it is inelastic, momentum is still conserved. So whether elastic or inelastic, the law of conservation of momentum means total momentum before collision and after collision are always similar. But in inelastic collision and elastic collision, there is one quantity which is not conserved, that is the kinetic energy. Just recently we have discussed about the kinetic energy. And you know the kinetic energy is Ek, and that is equivalent to half mv square. So please remember, in an elastic collision, both momentum and kinetic energies are conserved. Both momentum and Ek are conserved. But in the case of inelastic collision, still the momentum is conserved, but Ek is not conserved. So we decide on the basis of the kinetic energy whether the collision is elastic or inelastic. So please remember that we have to take care of the collisions in the case of kinetic energy. So the collisions are of two types. They might be elastic, they might be inelastic. Okay, so in any of the case, we are clear that conservation of momentum holds, but kinetic energy conservation doesn't hold. So according to the principle of conservation of linear momentum, we should always remember that the total momentum of a closed system, if you go to write the perfect definition of the law, the perfect statement would be the total momentum of a closed system is always, total momentum of a closed system is always conserved. If you can write it, it's okay. Otherwise, the total momentum of a closed system before collision is equal to total momentum after collision of the same system. Okay, so we can write it in these words as well, or if you say conserved, it means that it's before and after collision, it is exactly the same. Further, we have one more law, that is only when the collision is elastic. When we say collision is elastic, we say the Ek is conserved. Ek is conserved too. But there is one more thing which confirms this very good thing, that is the speed of separation, speed of approach is also equals to speed of separation. So speed of approach is also equal to, these are the two new things for you. What does this mean? Speed of approach, speed of separation. It comes when you are, when you just talk about the two vehicles moving on the road. If you are on a highway and your vehicle is going on the road, okay, your vehicle is running with a velocity, with a speed of, for example, 100 kilometers per hour. There is another vehicle which is coming from behind and it was traveling with the speed of 120 kilometers per hour. So when it crosses you, you cannot say that the speed of this vehicle is 120 kilometers because you are also at 100 kilometers per hour. So here you talk about the relative speed of approach, better towards speed of approach, relative. Sorry, I have forgot to write the word relative. So you write the relative speed, your relative speed, if you are body A, this is the car B, the relative speed of A in respect to B is just 20 kilometers per hour, because If you are traveling in the same line, the relative speeds are subtracted. And for example, if the two vehicles are going in the same direction with the same speed, this is also going with 120 kilometers per hour. This is also going, so their relative speed is zero. Their relative speed is zero. And if you see towards that vehicle, it seems the vehicle is not moving. Have you observed it? This is called basically relative in relation to other moving body. A relative in relation to other body. And similarly, if the two bodies are going in opposite directions, one of the car is going in this direction and there is another car on the highway and that's going in this direction. And if you are going at 100 kilometers per hour, this vehicle is also going at 100 kilometers. So at the time when there is a crossing, if you watch that vehicle, it crosses you in a very short interval of time. It seems that the speed of yours is doubled. That's called the relative speed. So your relative speed right now will become 200 kilometers per hour, because when you are traveling in opposite directions, the speeds are added. You got it, Peter?
Yes, sir.
Okay, good. The speeds are added when you just are going in opposite. Now come to a practical example so that we can talk about the relative speed of approach and relative speed of separation. In my previous example, which I gave you, that there is a body whose mass is m1, is traveling with a velocity of u1. There is another body whose mass is m2 and traveling in this direction with velocity u2. And there had a collision. And after the collision, this body is also going with velocity v1 in this direction. Another body is also going in the same direction with velocity v2. Now, if I talk about the relative speed of approach, so here I apply the relative speed, because before collision, they are approaching towards each other. So I talk about the first thing. Here you can see both velocities are in opposite direction. So they will be added. So it would be u1 plus u2. This is the relative. And here they are going in the same direction. So it would be v1 minus v2 would be the separation. So the rule says the vu1 plus u2 would definitely be equals to v1 minus v2 if it is an elastic collision. But this sign is with the directions given. You have to decide about the signs after knowing the directions of the velocities, because there might be plus, there might be minus anywhere, depending upon the situation which is given to you. So in any given situation, you can talk about the relative speed of approach and relative speed of separation. All right.
All right, sir.
Good, beta. If you have got it, that is definitely good. That we would be coming it into different actual situations where we need these momentum, conservation of momentum, and we need to use this law and the values, and then we have to find the situation, and we have to decide whether the collision is elastic or inelastic. All right, just give me a second, beta. Now we'll talk about it, KG, whether it's an elastic collision or not. How? Checking the relative speed of approach and relative speed of separation. In this case, what would be the relative speed of approach? That's they are traveling in opposite directions, so definitely you have to add, and this is 3, 4, 5. The answer is simply 5. When we talk about the relative speed of separation, still they are going in opposite directions. If you add them, still we have the answer is 3. The answer is 3. It means they are not equal. So it is confirmed that this collision is not elastic. So directly, just this is a very simple shortcut of checking any of the collision that it is elastic or not? Relative speed of approach. Is it easy?
Sir, could you explain that again?
Yes, beta, I was explaining the same thing. If you have moving on your car, and if you're going in this direction, another friend's car is also going in the same direction, and if you are going with the same velocity, it means your relative speed is 0 because it is subtracted when the two bodies are going in same direction. But if the two bodies are going in opposite direction, their relative speed is added. Just to remember this. In this case, you can see both the bodies are going in opposite direction, arrows are indicating. So you need to add them for the relative speed of approach, which is 5. And in the other case, the velocities are given, still they are going in opposite directions. Whenever the two bodies are going in opposite direction, we have to add it. The relative speed is now 3. Both are not equal. If they are not equal, it means it is an inelastic collision. This is not an elastic collision. Just we can decide by knowing relative speed of approach and relative speed of separation. ये result आ जाएगा हमारे पास बेटा. तो simply हम बड़ी आसानी के साथ देख सकते हैं. But situation should be given कि इस situation में हम ये देखें कि ये collision elastic है या नहीं है. कैसे देखेंगे? हमने दोनों velocities को add करना है. अगर वो opposite direction में है, अगर सिमिलर डायरेक्शन में है तो फिर सब्ट्रैक्ट कर देना है, क्योंकि ये दोनों ऑपोजिट डायरेक्शन में है, बिफोर भी आफ्टर भी, तो दोनों को ऐड किया, एक का आंसर 5, एक का आंसर 3, बराबर नहीं आया, इसका मतलब है कोलिजन इज नॉट इलास्टिक. ठीक हो गया बेटा?
जी सर.
गुड. इसका मतलब ये हो गया कि कोलिजन्स आपकी परफेक्टली इलास्टिक भी हो सकती हैं और कोलिजन्स आपकी इनइलास्टिक भी हो सकती हैं. देयर आर टू पॉसिबिलिटीज ऑफ द कोलिजन्स. इफ दे आर like that, then we have to talk accordingly. एक और situation की बात करते हैं जी. I have a situation and now let's talk about that situation कि आपके पास जो है वो before and after the collision, because हमारे पास दुनिया में बहुत सारी चीजें हैं, जैसे explosions हो रहे होते हैं, चीजें collide कर रही होती हैं, but we have to talk about the conservation of momentum and law of conservation of momentum, और different situations को हमें देखना होता है. Now देखिए question इस तरह से given है आपको. क्या गिवन है कि एक बॉडी 5 kg की है, दूसरी 1 kg की है. ये बॉडी 10 मीटर किससे ट्रेवल करती हुई आ रही है. ये बॉडी डेफिनेटली यहाँ पर रेस्ट पर है, इसकी कोई स्पीड नहीं है, रुकी हुई है. बिफोर और आफ्टर का जिक्र भी गिवन है, पॉजिटिव डायरेक्शन भी बता दी उसने. 5 kg की वेलोसिटी 10 से चेंज होकर v हो जाती है, जबकि आपकी 1 kg की बॉडी 10 मीटर पर सेकंड से दौड़ने लगती है. नाउ वी हैव टू फर्स्ट ऑफ ऑल फाइंड ये कि v को फाइंड करें. पहला काम ये. एक बात क्लियर है कि मोमेंटम हमेशा कंजर्व रहती है. अगर मोमेंटम कंजर्व रहती है तो टोटल मोमेंटम बिफोर कोलिजन की बात करते हैं, तो टोटल मोमेंटम बिफोर कोलिजन इज 10 into 5 plus 1 into 0 and must be equal to total momentum after collision 5 into v plus 10 into 1. All right, so इस इक्वेशन से बड़ी आप आसानी के साथ ये 50 और ये इधर आके 10 minus is equals to 5v, 40 over 5 is equals to v. तो आपके पास v की वैल्यू आ जाएगी कि ये वेलोसिटी कितनी होगी. We can get it easily. तो what I have applied? I have applied simply the law of conservation of momentum. अब इसकी वेलोसिटी आप 40 over 5 करें, 5 8 आ रही है मेरा, ऐसी है ना बेटा, 8 आती है. तो इसकी वेलोसिटी का पता चल गया, वो 8 है. अब जरा हम इसके ऊपर बेटा लगाते हैं वेलोसिटी ऑफ सेपरेशन एंड वेलोसिटी ऑफ अप्रोच. तो लॉ ऑफ कंजर्वेशन ऑफ उसको चेक करते हैं कि है कि नहीं है. देखें आफ्टर कोलिजन ये 8 और ये 10 सेम डायरेक्शन में जा रहे हैं. इसका मतलब है जब आप रिलेटिव स्पीड ऑफ अप्रोच की बात करेंगे तो या तो वो 8 minus 10 होगा या 10 minus 8 होगा. डेफिनेटली आपका आंसर आ रहा है -2. इधर अगर हम बात करेंगे बिकॉज दिस इज एट रेस्ट, इसकी तो कोई वेलोसिटी नहीं है, तो आपके पास अप्रोच के अंदर जो है वो इसके हिसाब से जो अप्रोच होगी वो 10 ही होगी, क्योंकि 10 plus minus 0 10 ही आता है आंसर. आपने देखा दोनों बराबर नहीं है. इसका मतलब है दिस कोलिजन वाज नॉट इलास्टिक. लेकिन इलास्टिक कोलिजन की एग्जांपल्स भी हमारे सामने आएंगी. सो इन शॉर्ट बेटा, what we have to do and what we have to remember that in different situations, whenever we have any kind of the collision, then the collisions can be of two types. It can be perfectly elastic or it can not be perfectly elastic. And what to remember beta, we have to see three things: momentum, kinetic energy and total energy. In any case, if the collision is perfectly elastic, momentum definitely conserved. Not conserved वाली तो बात आप काट देना, हो ही नहीं सकता. Kinetic energy भी conserved, ये भी not conserved नहीं हो सकती. If it is a perfectly elastic collision. Total energy तो हमेशा conserve होती है, not conserve को भूल जाए. But in an inelastic collision, momentum is still conserved, but the kinetic energy is not conserved. लेकिन total energy हमेशा conserve रहती है बेटा. Total energy के अंदर kinetic और potential के अलावा other forms of energies भी बेटा आ जाती हैं. ठीक है. Please remember कि जब भी टाइप्स ऑफ कोलिजन की बात होती है, परफेक्टली इलास्टिक कोलिजन में मोमेंटम भी कंजर्व, काइनेटिक टोटल एनर्जी तो हर हाल में कंजर्व रहती है, और दूसरी बात मोमेंटम भी हर हाल में कंजर्व रहता है, चाहे इनइलास्टिक कोलिजन. लेकिन एक चीज है जो इनइलास्टिक में कंजर्व नहीं होती, और वो है काइनेटिक एनर्जी. और याद रहे, परफेक्टली इलास्टिक कोलिजन के अंदर एक और जो रूल है वो है रिलेटिव स्पीड ऑफ अप्रोच is equals to relative speed of separation. Please follow this as well. And this is a very shortcut rule and a very precise method of checking any kind of collision, that this collision is elastic or not. If it would be elastic, then definitely we can talk about it very quickly. All right.